Today we will be going over the areas of a triangle, and to start it off we will be defining what is area. And area is the number of 1 by 1 squares that can fit into any given shape. And the example of an area that I'll be using at first is the area of a rectangle. And so here I have a drawing of a simple orange rectangle here. And we know that the area of a rectangle is length times width. So here we can see that going up and down here is the width, and going across is the length. And so here I've divided our rectangle up. I've divided our rectangle up with these lines here, and we can figure out the area in two different ways. So we can either count the number of squares throughout the whole rectangle, or we can just count the number of squares going around it. So for the width here, there's 1, 2, 3, 4. So there's 4 squares going up and down the width. And for the length, there's 1, 2, 3, 4, 5, 6. 6 squares across for our length here. And we can just plug that into the formula. 6 for the length and 4 for the width. So now that becomes 6 times 4, which means that the area of this rectangle will be 24. However, the focus of this video is trying to find the area of a triangle, and we know that the formula for area of a triangle is 1/2 times base times height. And the reason for this is because most of the time a triangle is half of a rectangle, and I am going to be demonstrating how the area of a triangle is 1/2 times base times height using 3 different triangles. And the first triangle will be the acute triangle, where the length is down the center. So the length will be, the height will be going down the center right here. And the second triangle is the right triangle, where the height is on the outside of the triangle. And then finally it will be the obtuse triangle, where the height will be on the outside again, but then we will be drawing that in later. So I'm going to start off with the acute triangle here, and we already know that we want to prove that the area is 1/2 times base times height. So what I'm going to do first is divide our acute triangle here right down the middle, so that's where our height is. And next we're going to rotate these triangles up. So we're going to rotate them up on both sides of the triangle in order to create our rectangle. So here's our rectangle with the 90 degrees on all 4 corners, and our base remains the same down here. And because our height goes right down the center of this acute triangle, that is how this becomes 1/2 times base times height. And so with our second triangle here, our right triangle, our height is right here on the outside, and our base remains down here at the bottom as always. And what I'm going to do is just going to rotate this whole triangle to this area up here to create our rectangle. So we have our 90 degrees again, and we can clearly see that this triangle is half of this rectangle, so that's why this becomes 1/2 times base times height as well. And our obtuse triangle down here is the most complex one, because we have to create the height ourselves. And so what I'm going to do is draw in dotted lines to create the height for this triangle, and we'll label this piece down here X, and the base to our original triangle will remain as B. So this whole triangle here, I'm going to call it the big right triangle. And the formula for this triangle is going to be, see here, we're just going to label it big right triangle. And the formula is going to be 1/2 times X plus B times H. And then our small right triangle is the one that we just drew in here. So the formula for our small right triangle is 1/2 times x times h. So now what we want to do is to try to find the formula for our original obtuse triangle. So what we're going to do is we're going to subtract the small right triangle from the big right triangle, because we don't need this anymore. We're just basically using it to try to figure out the height of our obtuse triangle. So I'm going to take 1/2 times x plus b times h minus 1/2 times x times h. And now I'm going to distribute the height here in our big triangle formula, and I'm going to distribute it into our parentheses here. So now this becomes 1/2 times x times h plus b times h parentheses minus 1/2 times x times h. So oops, it should be like this. There shouldn't be a parentheses out here, so just let me get rid of that. There we go. So now this becomes, so now I'm going to distribute our 1/2 into our parentheses in here. So this now becomes 1/2, now we have the parentheses out here, times x times h plus 1/2 plus b times h minus 1/2 times x times h. And so now we can see that we have two of the same on both sides, and so because of that they will cancel each other out, which leaves us with 1/2 times base times height, and that becomes the area of our obtuse triangle. And these three examples are examples to prove how the area of a triangle is 1/2 times base times height.